Hello, everybody. This is a video part 2 on section 3.4. In the last video, I left off on problem 62, I believe, and I'm just going to pick up, excuse me, I'm going to pick up where we left off from problem 62. So here's that problem. So I've worked several problems from this set right here, 31 through 68. I'm going to try to do 68 as well. So let's look at that one. I'll write it down and then I'll zoom in so you can see what I'm doing here. So problem 68 says 16 take away 0.878 divided by 26 raised to the 3t equals 30. All right, so this is just one big number. I'm not sure what the point of this is. I don't know why they would write it this way. I mean, I could just, anyway, I could simplify this to a number. Let's see what I get. So if I change this to 16 take away 0.878 divided by 26. Yeah, it's not a very pretty number. It's not a fraction. It's not going to turn it into a fraction for me. So it's approximately, as you can see, it's approximately 15.97, right? So let me write this down. This is approximately 15.966. I'll just go to that many decimal places. Okay, so so typically what we do to get this, solve for this, we take the log of both sides. Now here, you can't really take the log with this as your base because it's kind of an undefined base, right? So I'm going to just take some other log. I'm going to try, let's just do a common log. So log, which is base 10, of 16 minus 0.878 over 26 to the 3t equals log of 30. All right, now, using the rule of logs, this can come out to the front here, right? So this becomes 3t times the log of all this, 16 minus 0.878 over 26 equals log of 30. Okay, now I can divide both sides by this number here. Now log of all this is just a number, so I'm going to divide both sides by that. So I get 3t equals log of 30 over log of 16 minus 0.878 over 26. And then I could just divide both sides by 3, which is just going to put the 3 down here with the log. So that'll be t equals log of 30 over log, 3 times the log, right? Because I'm going to divide both sides by 3, so of this. So let's see what this approximates. So log of 30, log of 30 is about 1.477. and then 3 times the log of that. And up here, I already approximated that, so I'll do 3 times the log of 15.966, 3.610, 3.610. All right, and when I divide that, 1.477 divided by 3.61, I get about 0.409 for t. So t is approximately 0.409. I think I'm going to pause this and check out and see if that's actually the correct answer. I'm curious. So give me just. Okay, and that is the answer that they have in the back of the book. They use the natural log instead of what I did, which is use common log, but it doesn't make any difference. You can use whatever log you want, right? But we do get this value right here. All right, so enough of that set. Let's look at the next problem set, 69 through 76. It says use a graphing utility to solve the equation, approximate the result of 3 decimal places. So here, all you have to do is graph both sides of the equation and see where they intersect, right? So for instance, number 70 here. That's not what I wanted to do. I think you can see this over here though. So I'm doing 70 here, so I'm going to go to y equal, and we're going to get rid of what's in here. All right, so I'm going to put in -4 e raised to, so that's second ln, e raised to, -x minus 1, -x minus 1, close that parenthesis. All right, plus 15. And we're looking to see where it crosses 0. So if I wanted to, I could graph 0, but when I graph y equals 0, that's just the x-axis. So I'm looking for where this, since it's equal to 0, I'm looking for the x-intercepts, right? Now let's see, this is plus 15, so that tells me it's going to cross the y-axis kind of high, but let's see what we get when we graph that. And I can see that it crosses right here. It looks like -2.5, I'd guess, but I'll just go to second trace. And since I put in both equations, I could use the intersect function on here. So it's telling me that I'm on the first curve right now. And that's the y-intercept right there, 13.52. But I'll hit enter, second curve, enter, guess, enter. There it is. So -2.322. -2.322 is the my approximate answer. So x is approximately -2.322 according to the graph. And this is verify algebraically. So let me do that. So let's write this down. -4 e raised to the -x minus 1 plus 15 equals 0. Right, so we're going to isolate this e raised to that power. So the first thing I'm going to do is subtract 15. So now I've got -4 e to the negative x minus 1 equals negative 15. Now I'm going to divide by, excuse me, I'm going to divide by negative 4. So e to the negative x minus 1 equals positive 15 over 4. That's what I get when I divide both sides by negative 4. Okay, now since it's e, I'm going to take the natural log of both sides. All right, and natural log of e of this is just the exponent, so everything cancels except the exponent. And I'm going to add 1 to that, and then change the signs, right? So add 1. Change all the signs. I'll just do it like this. Just make that whole side negative. Like that. All right, let's see if that gives me this value. All right, so negative natural log of, I better put a parenthesis in the front, so negative parenthesis natural log 15/4 plus 1. And as you can see, did I get it? Yes. Here's the value I'm trying to match, and it matches up. All right. So that's how you do this set. On, excuse me, 77 to 104, solve the logarithmic equation algebraically and approximate result to 3 decimal places. Okay, so we'll do an easy one. We'll do 78. Natural log of x equals 2. And note that's base e, right? So, in other words, you could write this as log base e to the x equals 2. So now I can convert this into exponent by doing e to the 2 equals x. And e squared is approximately, let's see, e squared, 7.39, approximately 3 decimal places, 7.389. All right. That's it. So let's look at another one. That was 78. We'll do 82. Log base 10. I'm not going to write the 10 because it's not necessary when it's 10 equals 2. So now it's 10 to the 2 equals 3z. So that's 100 equals 3z, so it's 100 divided by 3, which is approximately what, 33 1/3, I guess. So it's exactly 33.3 repeating. No need to round, right? I don't have to approximate it. That's an exact answer. Did I do that right? Yeah, 10 to the 2 equals 3z. Yep, that should be right. Okay, let's look at 84. So 5 times the log base 10 of x minus 2 equals 11. So first thing I want to do is divide by 5. I want the log to be alone. So it's log of x minus 2 equals 11/5. Now that's base 10, so 10 raised to the 11/5 is equal to x minus 2. 10 to the 11/5. And then I'll add 2 to that. Raised to the 11/5. Whoops. What is 11/5? Like 2.5? I better put that in parentheses. So that's 158. Let me see. 10 raised to 2.5. Nope. That's weird. Oh, it's 2 1/5. So it's 2.2. 2 1/5. There we go. So, and then if I add 2 to that, I get 160, right? So plus 2. So 160.489 equals x. All right. So that was problem 82. Scrolling down with these square roots, let's do 88. So natural log square root of x minus 8 equals 5. All right, so when you have a square root, that's the same as 1/2 power. So I'm going to rewrite this as x minus 8 to the 1/2 power equals 5. Oh, what can I do? I can bring that out front, right? That 1/2 can go out front. Is that what I want to do? Well, let's see. There's a couple ways I can go. So let me go a couple different ways and see what happens. Remember, natural log is log base e. So if I do it this way, the e to the 5th is this, right? So over here, I'll do e to the 5th is x minus 8 to the 1/2. And let's see what happens if I do that. So, e to the 5th is just a number. I can get that. So, e to the raised to the 5th. That's about 148.413 equals x. Basically, I can switch this back, square root of x minus 8, right? So now I could square both sides, I guess, to get rid of that square root. So if I square this side, I'll get a very big number, 22,026. 0.466 equals x minus 8. And then we'll just add 8. And I get that. 22,034. All right, so that's one way to go. Let me see how else I could do. I'm thinking about bringing this 1/2 out front. So 1/2 log base e of x minus 8 equals 5. Now I could To get rid of the 1/2, multiply both sides by 2, right? So if I multiply this side by 2, the 1/2 goes away. So I get log base e of x minus 8 equals 10. Okay, now I can change it to exponential. So e to the 10 equals x minus 8. And e to the 10, let's see, e raised to the 10 is 22,026. .466. So same as what I got over here, right? Equals x minus 8. And now if I just add 8, I'll end up with that answer right there, right? So the results are the same either way you go here. So as you can see, there are different paths that you can take to get to the solution to these problems. So that was 88. All right, let's look at some of these down here, like 92. So natural log of x plus natural log of x plus 1 equals 1. All right, well, when I see the addition, I can simplify this and write it as 1 log. So this would be natural log of x times x plus 1 equals 1. And natural log is base e, so this could be e to the 1 equals that. So e to the 1 equals x times x plus 1. And this is quadratic, isn't it? So this is e equals x squared plus x. I'll bring that e over, so now I have 0 equals x squared plus x minus e. Quadratic formula, right? X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So negative b is 1, so it's negative 1 plus or minus the square root of b squared, which is 1 squared, which is 1, minus 4 times a, which is 1, times c, which is negative e, over 2 times a, which is 1. So let's see, x equals negative 1 plus or minus the square root. This is what, 1 plus 4e over 2. I've got two answers here, right? So the square root of 1 plus 4e is about 3.446. Sorry, the square root, the whole square root part. So now I've got negative 1 plus or minus 3.446 over 2. So I need both of those answers. So I'll do 3.446 take away 1 divided by 2. So one of the answers is about 1.223. 1.223. I'll just do 1.22. And then another answer is negative 1 take away 3.446 divided by 2, negative 2.22. let's see if my calculator agrees with these answers. So I'm going to graph this equation, original equation. So y equals, this is going to be 1 down here because it's equal to 1, right? So natural log of x plus natural log of x plus 1. And, whoops, that's not what I wanted to do. And I also need to graph 1. I'm graphing both sides of this equation. Graph. There's 1. So one of these answers is not, all right. Yeah, one of these answers doesn't work because it's not in the domain. And I'm pretty sure it's the negative one, right? X cannot be a negative number. So this one's outside the domain. So it should be just 1.22. All right, let's see. Second trace, intersect, inner. Oops. Inner. There it is. As you can see, it's 1.2228. All right, so whenever you end up with a quadratic situation, it's possible that both of your answers could work. Just because you get a negative answer here doesn't mean it's going to end up being a negative in here, right? Like if I had gotten a negative 0.8, that wouldn't make this argument negative because negative 0.8 plus 1 would give me a little bit, it would give a positive number. So just check them. Make sure you check them. All right, so as you can see, they're getting a little harder, coming out to be quadratic expressions. That was number 92. All right, let's look at 96. I have not worked these out beforehand, so it's very possible I will run into a jam and make a mistake. And if you catch it, please let me know as soon as possible so I can give you some extra credit. Equals natural log of x. All right. Well, I could put these together as a single log. So natural log of, it's subtraction, so that's going to be a division. So that's x plus 1 over x minus 2 equals natural log of x. So now, since these are both natural logs, these arguments must be equal. So x plus 1 over x minus 2 is x. Now you're just doing algebra. So I'm going to multiply. Now remember, x cannot equal 2, right? X cannot equal 2. And as you can see here, x can't be 2 because 2 minus 2 is 0. And can you take the natural log of 0? Natural log of 0. No, it's a domain error. All right, so I'm going to multiply both sides by x minus 2. So that's going to give me x plus 1 equals x times x minus 2. Distribute this. So x plus 1 equals x squared minus 2x. Let's take these over here. So this is 0 now, equals x squared minus 3x minus 1. I'm pretty sure this does not factor, so we'll do the quadratic formula. X equals negative b, which is 3, plus or minus the square root of b squared, which is 9, minus 4 times a, which is 1, times c, which is negative 1, all divided by 2, a, which is 1. x equals 3 plus or minus the square root of, what is that, 9 plus 4. So square root of 13 over 2. So I'm pretty sure there's two answers here. Square root of 13 is about 3.606. 3.606. So we'll keep that in mind. So when I do my two solutions, I do 3 plus that. So I'm going to add 3 to that, and then divide by 2. And I get about 3.303. So that should work. I don't see any problems with the original. There's no domain errors there. But this other one, 3 take away 3.606, is going to give me a negative. So it's not going to work. 3 take away 3.606 is a negative. When you divide by 2, it's still a negative. So that number can't work, because that would make this here a negative, wouldn't it? So it should just be this one. So let's graph it and see if it works. Natural log x plus 1 minus natural log x minus 2, and then also natural log of x. You should cross it 3.3. There they are. So I'll do second trace intersect. First curve. Notice there's no y value, so I need to move to the right till I get in the right domain, till a y value shows up. There we go. So now I can hit enter. Enter, enter, enter. There it is, 3.303. All right, so that was 96, problem 96. And they all kind of work the same. Let's do 100, and I'll stop there. I guess I need to work a couple of those. So 100. Log base 2 of x plus log base 2 of x plus 2 equals log base 2 of x plus 6. So this should work out really similarly to the last one. We got addition, so we can rewrite this as log base 2 of x times x plus 2 equals log base 2 of x plus 6. And then you can get rid of the logs now, so x times x plus 2 equals x plus 6. And you have a quadratic again, and then you'd use the quadratic formula, or if you're lucky, it will factor. And I won't continue with that. It's pretty much the same stuff as what we did right here, this problem here. Let's see. So in exercise 105 to 108, use a graphing utility to solve the equation, approximate the results to 3 decimal places, verify your results algebraically. So I think I'll just do the algebra first. Problem 106. 500 equals 1500 e to the negative x over 2. So first thing I do is divide both sides by 1500. So 500 divided by 1500 is 1/3, right? Do math frac, it's 1/3. So this is 1/3 equals e to the negative x over 2. All right, so now you can switch this to a logarithm, right? If you can't remember the rules of a logarithm, you can just take the natural log of both sides and it should fall out. But I think it's going to be natural log of log base e of this equals this, right? So by memorization, it should be natural log of base e of this equals this. Okay, now what if you can't remember that? Well, then you can just take the natural log of both sides. So natural log of 1/3 equals natural log of e raised to the negative x over 2. And if you remember, whenever that's base e, so log base e of that, then the answer is just the exponent. So you get natural log of 1/3 equals negative x over 2. All right, so there's a method to this madness that we memorized earlier. So now I'm simply going to multiply by 2. So multiply both sides by 2. So this would be 2 times the natural log of 1/3 equals negative x. Switch the negative, so now I've got negative 2 times the natural log of 1/3 is x. And that is approximately, let's see, negative 2 natural log of 1/3. 2.197. 2.197. All right, and they want you to graph it. It says use a graphing utility to solve it. So now the problem here is when you graph this thing, these are pretty big numbers, right? Y equals like 500. And this is 1500 e raised to the negative x over 2. So when you go to graph this, you're not even going to probably see anything here. The reason is they're way, way up on the y-axis because of these large numbers right here. So what do I do to see where they cross? Well, I need to go into my window and I need to change that y max to like maybe 1500. I don't know. I'll try 1000 to see what happens. And when you change it to 1000, you're not going to want to count by ones on the y-axis, just too much. So I'll count by hundreds. See what that looks like. There's 500. There it is. So we can see now where they cross. So if I do second trace intersect, enter, enter, enter. And you see I get that 2.197 right there. Okie doke. So that is problem 106. And here we have compound interest. I'll save this, I think, for another day. That's enough for now. All right, appreciate you guys hanging in there. Hope you have a great day. God bless y'all. Bye-bye.